Are you a data scientist who doesn't want to have anything to do with the SQL part of the data warehousing project? Or are you a database administrator that doesn't know a lot about data science but would also like to do AI in their solution? Today we have an answer to both. Hello everyone, my name is Yulia. I usually make videos about data science and my life in tech here on YouTube, and I'm also a cloud solution architect for Microsoft. Together with one of my colleagues, we held this demo live for about 200 customers last week, but I thought it would benefit a larger audience as well. So I'm going to be uploading the part about integrating Azure Synapse with Azure Machine Learning and creating a demo for that. The rest of the demo, which is my colleague Renee talking about SQL and Azure in general, will be posted in a link in the description as well. Enjoy.
Okay, so Renee gave you guys the introduction of Synapse as your data warehouse and your data environment. And now I'm going to talk about how you can add machine learning models or data science practices on top of that using the integration that we have with Azure Machine Learning. So I'll start with just presenting Azure Machine Learning as a standalone product, which is what you would use for any sort of data science experiments or people who want to create models. And then I will show you how they integrate together so everything can be done in one place. So starting with Azure Machine Learning, I want to first say where it fits within Microsoft and its AI options. Like Renee mentioned before, it's like a chocolate box of so many different ways that you can do AI or you can do analytics. And machine learning is one of the options we have, especially for custom models. So there are things like AI agents or knowledge mining solutions that come more out of the box. But if you want to have a hands-on approach and design yourself how the model works and what it has to do, then in machine learning, you can make that more customized. So it's what we're going to be focusing on today. Why would you do machine learning? Of course, there's a lot of scenarios that you can create with these kind of models, starting from predictive maintenance and fraud detection, which can be, of course, in different parts of the bank. There's recommender systems, there's demand forecasting, sales. You can use it in HR, you can use it in your business lines, you can use it to optimize your employees' workloads. The possibilities are endless. So what we offer is not models that you can deploy. We offer the platform on which whatever your idea or your business case is, you can make that happen with all the benefits of Azure that Renee mentioned in the beginning. So still scalable, still easy to maintain and easy to deploy. There are a lot of ways in which you can do machine learning. So even if you want to do it customized, it's good to know that you can choose kind of how much of a platform you want or how much of infrastructure you want. So starting at the bottom, we have a lot of different infrastructure options with like virtual machines that have CPUs or GPUs or FPGAs, a lot of different types of memory optimization or speed or storage, depending on your needs. You can use that to power your own models. You can use Azure Machine Learning where everything comes into a UI, easier to look at and easier to work around with, similar also to what Databricks offers. Or the higher up you go, the more out of the box things would be. So for example, at the very top, we have our custom vision and speech and other cognitive services where you can reproduce human behavior in models. And these ones just come, like I said, out of the box. So you can also add that. And those actually also integrate with Synapse Analytics. Good to know. So if you ever want to add some of these functionalities, that's also possible. But what is then the benefit of Azure Machine Learning? Like I said, it's a platform. And if we look at the way that a machine learning project would look like, going from start to finish, similar to the flows that Renee was describing, we always start on the left with data that has to be stored somewhere so that you have access to it. If it's structured or not, doesn't really matter. Then you would have to have an infrastructure that you run things on. If you do that locally, it's usually your laptop. If you do that in a VM in the cloud, then it's the virtual machine that you chose. Or if you want more specialized things, you can have different clusters that are distributed, like the example for the SQL processing. It's sometimes beneficial to spread out the computations that you have. You can use something like a Databricks engine that has Spark, Yeah, again, a lot of different options here. And then going more towards the right, you would have to then deploy your model somewhere, which would either be a Docker container or a Kubernetes. Those are the most popular options if you want to have an instance of your model containerized somewhere, or again, have some sort of distribution system for it. These are a lot of services, right? If you look at this slide, there's a lot of logos and a lot of options because we want you to have that choice of what's the best fit for you. However, then the same story as with Synapse, if you would deploy all of these separately, you would also have to take care of the integration between them, the security concerns, the governance, even though even in this slide, of course, it's all surrounded by Key Vault and a VNet. So a Key Vault, for example, would store all your passwords so that they can communicate in between, and you don't have to code your passwords or your connectors in any way. And you can have firewall around all these services. So a solution like this would work for machine learning. However, the thing that Azure Machine Learning does is it kind of abstracts all these types of concepts and kind of does the best fit for all of them into one service that is just called Azure Machine Learning. So within Azure Machine Learning, you have different components that represent those parts of your pipeline. You have data stores and data sets that are ways to connect to where your data is stored. You have machine learning compute that can be a selection of different types of infrastructure that you could choose. You have experiments that allow you to track what your people are doing. So if a large team of data scientists works together and tries out different models with different parameters, you could see the past history of those runs and have a way better organization of what you're doing. And then when your models are done, you can register them. So you can have a catalog of all the models that have been created. You can have tags for them. You can know what version they're in. So again, everything's a bit more structured. And you can have endpoints that behind this could be, again, Kubernetes. It could be Docker. It could be an Azure container. It doesn't matter as long as you know it's an endpoint. So basically, you have the same type of flexibility that the cloud has with all the varieties of solutions you could use. But to you, it's just 5 components that are the basic building blocks to make a machine learning model. So as a data scientist, which is my background, I'm not a SQL person. I am not great at data things. So seeing this is a lot easier for me to not have to worry about how is the data going to be organized or how is the deployment going to work. I just have to focus on having these features and making use of them. So with that being said, the way that you usually use Azure Machine Learning would be in a portal. That's the experience that we offer. It's also for Synapse, also has a portal, and like Renee was showing, you can also interact with it in different ways. So the portal is kind of the user interface for it. Here on the left, you see the different building blocks that I mentioned that you can access from here. But in the same way, we want to have an experience that works for every type of user. So if you don't want to go on a website and click things around, it's also possible to connect to all this technology and all this benefits via the command line or via your favorite code editor as well. So you could just use Visual Studio as your interface and have all these benefits, just as well as you can use this website. But for today's demo, I'm going to show everything in the website. So yeah, we're at the part of the demo. So I think it makes more sense to actually show you guys around this portal and so you know how it runs. So this is the home of your Azure Machine Learning. You can have different workspaces for different projects. I'm in a demo workspace that has all these different experiments together. That's also something that's useful if you have workspaces for different teams, then you know who has access to what. It's not a free-for-all, so that keeps things very well governed and very organized. So here on the left, like I said, is your menu where you would go to all the parts that you want, starting with the foundational parts, compute, first of all. So this is the infrastructure that everything you have runs on. This is the cloud version of your laptop. You see that there's different types of compute. That's, again, because of all the chocolate options that you would have. What I normally use is a general virtual machine that you can run most of your scripts on. So you can see here the type of machine it is, but you can make it as big and as strong and as expensive or cheap as you want it to be. And this I just turned it on to show you how it works, but as soon as I'm done with it, I can turn it off and then it's not consuming things anymore. However, a virtual machine, especially this one, is CPU based, so it's as good as having your laptop, only in the cloud. However, when you're training like a deep learning model or something very complex, then your laptop is not good enough unless it's super, super heavy and annoying to carry around. Similarly, with the cloud, you would then have to do a different type of compute, which we call clusters. So these ones have different number of nodes that can distribute your tasks to make everything parallelize and everything run smoother. So these are clusters that I would use for training my model. You can think of this as having different hammers for different nails, right? So you don't want to have a super, super strong compute instance that's overpowered that you use to run things like a hello world script, right? That would require a very small amount of infrastructure. But then when you want to train a neural network, that will require a lot more. So you have the option to choose, I want to run my first script on the instance, and then for the heavy stuff, I'll use the clusters. And these ones, you can see I have 0 nodes now because nothing's actually running. And as soon as I send a task to them, they will scale up and create as many as I put the max to be. Then we have inference clusters, which are used for your endpoints. So once a model has been deployed, and with attached compute, you can actually bring in compute from other Azure services, such as Databricks or HD Insights. If you want to have Spark capabilities, but today the Spark capabilities we'll use will be actually from Synapse Studio. Okay, another thing I want to show you here is the data stores. What these are kind of linked services. So my data is perhaps in a data lake somewhere. Then this will make a connection to that data lake, but it won't actually move the data into this new service, which is a lot safer, of course, and easy for tracking the history of that data and the lineage. So I don't move it around. I can just connect to it and make data sets from it that I can use. So data sets are different kind of files that I select that I want to use for a project. So the same data set that Renee was working with is the New York City taxi data. So I've made this data set in here that has all that information, and you can see here like I have like an explore button to have a quick view of it. So I don't have to open the data separately, or I don't have to run the SQL window to look at it. It can all be in this one window. So this is the data that I'll train a model on today. Now, the way to train those models is, of course, via writing a machine learning algorithm. You can do that with notebooks. I have here some notebook examples that are running. And again, this can all happen in the same window, or I can open it if I want in a Jupyter Lab or in VS Code. So actually, I think I have that open. See if I want to run from a code editor, it's the exact same experience. This can connect to Azure and it will run just as well. And with this code, you would then choose, here you see which cluster I want to run it on. And when you write all these commands, then the processing will happen in the cloud. If you don't want to use code and you prefer to use a drag and drop tool, we have a designer. As you can see from this example, there is no code here, but this is a complete machine learning model as well, starting with, oh, I want to use this data, I want to do some transformation, I'm importing this module, this model that's I think, regression, and then execute something and you have an output. So this also allows people who have low coding abilities to create a machine learning model as well. And even more than that, we have autoML, which is what we'll use today, which is kind of an in-between. You don't have to code, but you kind of have to understand what you're doing in the way that I will give it all my data, I will give it a target, and then it will automatically run through like hundreds of models with different parameters to see what the best model is automatically. But I'm not going to run it from here. I want to run it from Synapse. This is the Synapse portal that we have, the service that Renee has been presenting this whole time. I can access it from my Azure portal. And again, on the left here, very similar design. I have all the options that I can go through, starting with the data. I can have a SQL pool that is connected to this environment, or I can have a Spark pool, or I can have both. Similarly, I can have a notebook that I want to run. So this is a notebook that I've created that is written in Python using Spark. And what this does is it gets the data from the New York City cabs and it registers it on my SQL cluster. So that's what I've done. Of course, I've split it into a training and a test part since I want to create a machine learning model. And this has put my data in here. So if I look, for example, in the Spark one, I see that I have the New York City data stored in here. I can see like all the columns that it has and whatnot. And what I can do, and this is the cool part, is I can go on the machine learning option and say enrich with a new model. And this works because I've actually connected my Synapse and my Azure machine learning services. And that's been done through a linked service. Since everything is on Azure, of course, it's quite well integrated and all these things can be connected with each other. So you can see that it knows that this is the workspace that I've connected to, this workspace that I've been showing all this time called demos. So I select that. I say that I want to predict the fair amount. I want to run it on my Spark tool. And then I say what kind of task I want, which for me is regression. And this is how I want to evaluate my model and how many hours I want it to run for. Automated ML takes a long time since, like I said, it's hundreds of models. So you would then create that run and it would go into your notebook and start running. I've already done it in advance. I figured you wouldn't want to wait 3 hours for it to finish. So if I go to my experiments, I can see this Synapse demo Julia thing that I've been running. And in this experiment, again, I can see everything that's been happening. So I can see that, for example, I've ran all these different types of models that it's going to show me. And I can see all their names. I can see what their Spearman correlation score was. That's what I've chosen to test it on. And I can see how long they took. So for example, 17 seconds for a model is pretty good. I think most laptops wouldn't handle that as well. But my winning one has been voting ensemble. This has had the highest correlation score, so it has been chosen as the winner of this automated ML. So this is what this process would have done, is choose that model. So then once that has happened, if I go to my testing data that I have in SQL, you now have this model that exists in Azure Machine Learning, and as a SQL user, as a data warehouse user, I can choose to make predictions with that model without having to create anything in Python. So I would do enrich with existing model. I would choose the model that I've created, and it would then tell me, oh, I've seen that your data has these columns, and the input to that model is usually these columns. Of course, they match since it's the same data. That's how this works. And I want to predict this output. So if I say that, then it's going to create a stored procedure that I can use with SQL to get a prediction out of this model. So again, I've already done this, and I can see it over here. So this SQL code has been generated by itself. I can guarantee you I cannot write any SQL. So this has been created for me by Synapse Analytics just by the fact that I've selected those columns. So you can see that they're all casted to the right format. And I use this predict function using the model that I've chosen and using all this information. And the result is this output here. So this was my testing data that didn't have a fair amount. I could have changed the name to fair amount. But basically, it predicts how much a fare would cost from a taxi ride based on these different parameters that I had. And this works because my model has been created and has actually been stored here in the SQL table as well. So from this data warehouse environment, using mainly SQL code, I can now make predictions from this super advanced model that's been created for me. and you don't have to know any data science to do it. On the other end of the spectrum, if I'm a data scientist, I can create a model in here without knowing anything about the SQL part, and then send it to the SQL data warehouse where someone else can use it. So you can see how both ends of the spectrum are very useful, and they're very well integrated, I would say, to make that transition very easy. So yeah, that's kind of what we had prepared, and I can now take some questions.
Thank you everyone for watching. I hope you found this useful, either if you're interested in the subject or you just want to see what a presentation given by a cloud solution architect looks like, especially live in digital times. Make sure to check out the rest of the videos. I have a series about data science on Azure, and I also make vlogs and other videos that are funny around data science. Check it out, and I'll see you next week.